Galvanic cells. Essentially, a galvanic cell consists of two half cells connected by a salt bridge. Each half cell contains a metal, an electrode, immersed into an aqueous solution containing the cation of the metal that is called an electrolyte. For example, a galvanic cell can have one of its half cells have a metal strip of zinc, the electrode, immersed into an aqueous solution of zinc nitrate, and the other having a strip of silver, the electrode, immersed in an aqueous solution of silver nitrate. A salt bridge can be in the form of a U-tube that contains an electrolyte. The ends of the U-tube are filled with a porous material such as cotton wool to allow aqueous ions to move into and out of its contained electrolyte. Such a galvanic cell can be abbreviated by what is called its cell notation, and this is given as follows. Zinc separated by a line there, you have zinc nitrate solution, a double line, silver nitrate solution, a single line, and silver. The single line represents the separation of the metal and its electrolyte, while the double line represents the structure such as a salt bridge that connects the two half cells. The working of a galvanic cell. The whole objective of the galvanic cell is to create a difference in electric potential between the two electrodes such that a current can flow between them if they are bridged by a metal wire. To explain how this happens, the cell that is referenced above is used. These are the two half cells. This one has a zinc rod that is called an electrode immersed in an aqueous solution of zinc nitrate. So that's a solution of zinc nitrate there. This other one has this silver rod, again it's called the electrode, immersed in a solution of silver nitrate. So that is a solution of silver nitrate. And these two electrodes, the zinc electrode and the silver electrode, are connected by a metal wire, such as copper. To know how electrons will flow from one half cell to the next, we have to determine which of the two electrodes, zinc or silver, is a stronger reducing agent, and which of the two sets of cations, zinc ions or silver ions, is a stronger oxidizing agent. From a table of data, zinc is found to be a stronger reducing agent than silver. As such, zinc atoms are changed into zinc ions, and the electrons produced are left on the zinc rod, making it negatively charged. In this other half cell, silver ions, being the stronger oxidizing agent, go onto the silver rod and absorb electrons from it, making it become positively charged. The discharged silver ions get deposited onto the silver rod as atoms. You can see that these silver ions that are present from the silver nitrate solution make their way onto the silver rod, where they collect electrons and get deposited there. By losing electrons to the silver ions, this electrode becomes positively charged. Because this electrode is now positively charged and this one is negatively charged, a potential difference is created between them, as a result of which, when a copper wire is placed between the two of them, electrons flow from the zinc rod into the silver rod. Because oxidation is happening at this electrode, it is called the anode, and because reduction is happening here, this electrode is called the cathode. Note how the part of the zinc electrode that is immersed into the zinc nitrate solution gets thinner, and the part of the silver electrode that's immersed into the silver nitrate solution gets thicker by virtue of silver atoms being deposited on it, and this one becoming thinner by virtue of zinc atoms being changed into zinc ions that dissolve in solution. Essentially, this is a single displacement reaction that is allowed to take place via these two half cells. One thing I want to bring your attention to is this. Initially, the positive charges due to the zinc ions were equal and opposite to those due to the negative charges found on the nitrate ions. However, since more and more zinc ions are being created, it creates an increase in the positive charges in the zinc half cell. So that shows the equality of the positive and negative charges that were there initially, but now all these ones here that are being created increases the positive nature of this half cell. Because the solution is becoming gradually more and more positive, it has a negative impact on the movement of the electron in that direction. In the other half cell, the opposite is happening. Initially, there were equal concentrations of positive and negative charges that were contributed by the silver and nitrate ions. However, as the silver ions are being changed to silver atoms, their concentrations decrease, causing an imbalance in the positive and negative charges initially present. In this case, there will be excess nitrate ions that make the solution become negative. And because of the negative nature of the solution, they will tend to repel electrons that normally come in that direction. So to rectify the imbalance of the electrical charges that are created in the two half cells, a salt bridge is made use of. In this case, the salt bridge is in the form of a U-tube, you can see U-tube here, that is filled with an inert electrolyte, which in this case is potassium nitrate solution. And at the bottom of the U-tube here is a porous material, which can be in the form of cotton wool. So this is what happens. Because the zinc half cell is increasing in its positive nature, nitrate ions that are negatively charged will seep through the porous material here to neutralize the positive charges that are created by the ionization of zinc. On the other side, positive potassium ions seep through the porous material to replenish any positive charges lost by the reduction of silver ions that get deposited as silver atoms on the rod. So we can see initially you had equal concentrations of these, but as those get deposited, you have an excess of nitrate ions, and that's why the potassium ions coming through there will be able to neutralize those. And that is how the imbalance of the charges that are created in those two half cells are rectified. These are some summary points to note. Determining which of the two metal rods is a stronger reducing agent, oxidation of its atoms will take place. In the case studied, it was zinc. The ions foam will be in solution and the electron produced will be on the rod, making it become negatively charged. And that electrode is now called the anode. The cations present in the other half cell, silver ions, being stronger oxidizing agent than zinc ions, absorb electrons from the silver rod, making it become positively charged, and that electrode is then called the cathode. And this is how a difference of electric potential is created between the two electrodes to allow a current to flow from the anode to the cathode. Number 2, the zinc electrode loses mass while the silver electrode gains mass. Number 3, the addition of zinc ions to the half cell creates an imbalance of the electrical charges there. There's more positive charges than negative charges. This has a negative impact on the movement of electrons towards the anode. They are attracted by the excess positive zinc ions. Number 4, the removal of silver ions in the other half cell also creates an imbalance of the electrical charges there. There's more negative charges than positive charges. The nitrate ions repel electrons tending to move towards the cathode. To rectify the imbalances of charges created both half cells, a salt bridge in the form of a U-tube is filled with an inert electrolyte. This is then inserted into the two half cells as shown in the figure above. The negatively charged nitrate ion diffuse into the anodic half cell to negate the effects of any excess zinc ions produced. The positively charged potassium ions diffuse into the cathodic half cell to negate the effects of any excess nitrate ions remaining there. So that summarizes everything that is shown in this figure. the net ionic equation of the cell reactions. To arrive at this equation, we're going to add the two half equations. So this is the oxidation half equation, and that is the reduction half equation. And we can see that this is a net ionic equation for the reaction. And of course, it is a single displacement reaction that is happening between zinc and silver ions to give you zinc ions and silver. That is allowed to take place in two half cells that helps to create a difference in electric potential between them that allows a current to flow.